Hello, I am Ryan Linn, and this is Collecting Underpants to Own Your Network. Oh yeah. So we're going to talk about a couple things today. First, we're going to talk about why we're here. That way you can figure out whether or not you want to be here or across the hall. We're going to talk about how this is going to help me and help you. And I think talk is boring, and I like show and tell a lot better. So we're going to do a couple demos, look at some stuff. And if you're still interested at that point, we're going to look at how this works. And then from that point, if you're interested in the code and a little bit more about the protocols, we're going to dig deeper. And finally, once we understand everything, we're going to talk about how to fix it. And if you think this is really cool and want to help me out, we're going to talk about that some too. So why are we here? We're going to talk about passive network information gathering. A lot of the time when you see passive information gathering, it's things like looking up stuff in Google and all of that. But when you're pen testing, one of the interesting things to do is just to look on the network and see what traffic's out there. It turns out that hosts are pretty noisy. So what we're going to look at is how to passively identify hosts and resources on a network. We're going to look at profiling individuals and applications, determining some network architecture, and also we can figure out some about the machines in the domain, the domain itself, and also the real interesting one is naming schemes. So the nice part about this is this project is completely silent. No man in the middle is required. So as far as network passive information gathering and network fingerprinting is concerned, there are some commercial products out there. One of the things that they like to do is inject themselves at the core of your network. So if you're a sysadmin on a local network segment or you're a pen tester, the chance that you're going to get a span port off the core is pretty slim. So my goal here is to start off with what we do have, which is usually we have some sort of network drop. And we may have it because we wandered in and plugged in somewhere, or we may have it because we were given a network workstation, or we just landed on the wireless. But the important thing is no attacks are required to do any of this. So if you're a sysadmin, it won't affect your network. If you're a pen tester, nobody's going to see you on an IDS. And pretty much the only thing that can back this as far as like listening to local network traffic is something along the lines of NAC, where you wouldn't actually be able to get a network link. So why are we here? To collect underpants. Well, who here is familiar with the Underpants gnomes from South Park? Okay, awesome. So the Underpants gnomes did three things. Well, they collected underpants, and they knew that they wanted profit, but they weren't sure about the middle thing. So for us, since we're not attackers and we're not trying to make money, we like winning. Pen testers like winning. And a lot of us like knowledge as well. So what we're going to try to do is we're going to try to fill in these question marks into how do we look at network traffic and then do something meaningful with it. So what I have done is taken some Metasploit sniffer code and allowed it to parse different types of packets on the network. What we're going to do is we're going to take those packets and insert them directly into the Metasploit database so that they're immediately actionable. We're going to talk a little bit about, that's awesome that we can stick them in there, but once we have captured all this information, how do we manage it and how do we look at it? And also what kind of information can we get through just broadcast and multicast packets on the network that can do anything meaningful for us? So how will this help us? As a sysadmin or a user, it's really good to know what types of information you're transmitting. A lot of the time, especially in Windows networks may be very noisy, and people don't even realize what types of information are being sent out. Network admins may not realize that they're broadcasting CDP or other configuration protocols that can give away information about their network. And as a pen tester, sometimes it's important to listen before you just go in and start beating the crap out of everything. Because, beating the crap out of everything is cool, but you don't really have an idea necessarily of what you're really looking for and what you're really dealing with until you listen a little bit. So as far as everyone goes, what I really hope to do is give you guys a framework for making some of this information gathering easier. And because we're using the Metasploit database, initially what we're going to do is gather information. Once we gather the information, we can actually leverage this information along with other information to directly gain insight into things we may wish to attack. We're going to talk about a little bit about how to organize and manage the results within Dradis. But the big thing is how to stay quiet on a network. Because like I said, none of this is sending out packets. So we can get a whole lot of information just by hanging out. So I think that's probably enough talking. So I'm going to do a quick demo of just some basic traffic gathering. We're going to look at the data for a second within Metasploit, and then we're going to look at the data for a minute within Dradis. So I guess I'll start off with, if people have questions, feel free to raise your hand. I've built in a little bit of time for questions. So if you have questions, feel free to ask. Questions yet? Okay. So let's see how well this works. Okay, cool. So that awesome sauce. So first of all, just to get sort of an idea for what is actually being transmitted on the network right now, there is a lot of information that's out there. So let me go ahead and change this a little bit. So just getting an idea of what hosts are out there, we can just listen to ARP requests, and we can sort of have an idea of what hosts are out there and are talking into who. So say you just plug into a port, you want to know where am I, when am I? ARPs are a good way to do that. You don't have to have an IP address. Just by sniffing, we can sort of tell some information here. We can guess at where the gateways are. We can guess at who the hosts on the network are. And again, this is not sending any traffic out. From here, I'm going to start off by launching Metasploit with its database backend. For people who haven't set up Metasploit before with the database, Postgres is the recommended database. Who here has used Metasploit before? Okay, so there are some people that may not have. Metasploit is a pen testing framework. It has a lot of features that aid pen testers in exploitation, also researchers and exploit development and testing. But where I use it for in my corporate day job is I use it a lot for testing. One of the nice things about this is these are the same types of attacks that attackers are going to be running against me and my enterprise. So I use Metasploit to verify that the constraints that I have in place, things like firewalls, proxies, IDS, that those things are catching the types of attacks that malicious people are going to try to do to me. So Metasploit is part of my toolkit for validating that the security constraints that I have are in place. So that's part of the reason that this is nice, because no matter what your role is, whether you're a network admin or a system manager, just somebody who's interested, Metasploit is sort of part of that security toolkit that most people are going to hold on to. So Postgres is the basic backend. So to build your Postgres database, you can SU to the Postgres user, and you can type in create user MSF. After that, that creates a Metasploit user for yourself. From there, I'm going to go ahead and get rid of the database I have. You do create DB, specify the owner to MSF, and we're creating a database called MSF. So we're going to go ahead and create our database. So as root, because it's hard to sniff while you're not root, we're going to, in this case, be using some PCAP files that I've already saved. But typically, if you're going to be using Metasploit and you need to have access to network traffic, being root is important. So we're going to run an RC file that I created. One of the nice things about Metasploit is it has the ability to create some RC files. And what the RC files do is it is just a set of commands that you want to run every time, because I get tired of typing them in every time. So we're going to go into MSF console, and we're going to load this file. This file loads the XML RPC module and sets the password equal to test, and then it connects to our new Metasploit Postgres database. So this will take just a second to load up. So the code that we're going to be looking at today is not currently in the main Metasploit branch. I'm going to put the URL up at the end. It's still something that I'm actively working on trying to get a little bit better before I hand it over to those guys. So I'll give you the subversion link. When Metasploit starts up, we're going to see it's creating all of our database structure, and when we see the MSF prompt, it means we're good to go. So the name of this module is called pig. So it lives in the auxiliary sniffer path. So from here, we have a number of options. Metasploit has some interesting features. One of the things that is cool but can sometimes be a pain in the ass is it lets you build upon classes. So there's this awesome class called the sniffer class for exploits, and it pulls all this stuff in, so I have to write like 2 lines of code. Unfortunately, for some reason, it is really interested in this rhost field, which, it doesn't actually do anything. So we have to set that. So for here, we're going to set our rhost to just our loopback. Next, we have the option to pick between an interface file or a PCAP file. We are going to use a PCAP file. And so from here, we're going to set our PCAP file to my home directory, demo1.pcap. So those are the only 2 options we have to set. So the protocols option we can set. There's a number of different protocols that we have available. To look at those protocols, they are in the Metasploit, and then under data and exploits, you go into the pig directory. These are all of the exploits, or all of the protocol parsers. To pick out a new protocol parser, pretty much all you have to do is create it and drop it in this directory, and the all directive will pick it up automatically. So now we're going to just type in run. And so from here, we can see a number of different types of hosts are picked up from the PCAP file. So basically, we just let this run through. And then when we're through, all of the information that's gathered so far is going to end up in our database. So we were able to pick up a couple of different things. We now have a number of different hosts, and we can get to the host by doing a db hosts. We can look at our services that it picked up by doing db services. So we can see here that there's a number of different hosts. We have the services that map to them. And the really interesting thing about this is the notes section. The notes section is where Metasploit puts all of the stuff that it doesn't really have a place to shove anywhere else. So all of this stuff is freeform, which is kind of good and kind of bad. The cool thing about this is if you're comfortable with Python or any other scripting language, all of this is stored in basically a JSON hash. So you can pull it back out and convert it back to a data structure to mess with it. So we have all these notes in here now, and so we can just browse through them through Metasploit, which that's a lot of stuff, and that hurts my head. So there's got to be a better way to do this. So from here, after I was playing with this, I started talking to the guys who did Dradus. Dradus is a documentation framework for pen testers that helps document notes and other information as you're going through a pen test and helps organize it. It can pull in information like packet captures and vulnerability scans, all of that information, and help you organize it. So where I went from here is, well, this is cool. What we really need to be able to make this useful for people is something like Dradus. So the next thing I'm going to show now that we have all this information, and we're going to talk a little bit more about what this information is once we have it in Dradus, and also once we start looking at what is part of each protocol, we're going to go ahead and launch Dradus. So who here has used Dradus before? Okay, so not many people. So Dradus is currently being rewritten and updated. Yeah, they're doing some updates to it right now, and they're talking about how they want to improve some of the aspects. One of the things that has been historically a problem with Dradus is people have had a hard time getting it running. So there have been some additional pieces to help get started. One of those is the bundle script. And bundle will go ahead and say, go ahead and install all of the gems that I need to run this. And so basically, if you just type from here bundle install, it'll go ahead and pull down all of the gems you need to run Dradis for Ruby on Rails and install them. So it's just one command. Once you've done that, Thor is the new manager. So by doing a Thor list, we can see all of the different things that Dradis can do. The first thing we want to do is start the server. So we're going to do a Thor Dradis :server. And Dradis has a web front end. So we can see right now it's starting up our web front end. It's starting up as HTTPS. So let's pull up our handy web browser. Let's try this. And let's try to make this a little bit better. So this is the Dradis main screen. Over here on the left is going to be where we have our, nodes about information. And over on the right is sort of the dig down into those information. The first thing we want to do is go into our configuration tab. And we're going to see a couple of MSF options. So for this, we want to make sure that our import host is 127.0.0.1. If you remember, when in our RC file, we specified our password to be test. The username is always MSF, and then the default port is 55553. So we have all of the configuration information that we need. So the next thing we're going to do is come back over here and background our Dradis server. So when we do a Thor list again, there's going to be a MSF import MSF all, import MSF all. So from here we can do a Thor Dradis import MSF all. And what this is going to do is reach into the Metasploit server, and it is going to grab all of the goodies we just captured. From there, it is going to put it into the Dradis database. So this is going to take care of building all of these relations and views for how all of this stuff is put together. So we can see that it was completed 200 OK. And so now we should be able to go back to our handy dandy web server. No, I don't need to remember that. Thank you, though. And as you can see, it's doing a lot of thinking in the background. But we'll go ahead and force a refresh of the tree. And depending on how many hosts, this may take a couple seconds. So now we have a Metasploit node. In our Metasploit node, we have a list of all of the hosts we have. So from here, we can dig down in, and we can look at individual ports. And when we click on the individual port, we see the note. To get more information from the note, we just double-click. And so now we can see the information about that service. So we know that UDP port was open. And so basically that was the main gist of that. So let me look and see if we can find some more interesting ones. So this one was from a Groove server that it detected. And we can see here the port that the Groove server was listening on, its IP address, and the Groove URL. So the other interesting stuff is we know, again, what port it's listening on, what its address is, but the version of the software. So this doesn't help us a whole lot, but it does tell us that it is a Windows box because it's running Groove. It also tells us if multiple people are connected to the same place, we'll know that. But we'll also know what the version is. So if you have different versions, it'll indicate different versions of Office. So that may be interesting if you're planning on doing targeted attacks for social engineering or something along those lines. If you're targeting specific versions of Windows, you can look for specific versions of Groove, and you can sort of glean from that what somebody might be running. Let's take a look at what else we've got up in here. So one of the other things I wanted to touch on is, who here has heard of the pwn plug? So this is a pwn plug, and this has Linux on it, it has Metasploit on it, and it also has the ability to do wireless sniffing. So basically the cool thing about this is you can put like CO2 detector or something along those lines, drop this somewhere, and it can just sit and listen for an indeterminate amount of time. Since it's running Linux, it also has the ability to do some other cool stuff. Built in, there are some scripts to help do SSH tunneling. So if you're somewhere where you're pretty comfortable you'll get an IP address, then you can tell this guy to connect back home. You tell it where home is, and it will start working pretty hard for you. First, it will try to SSH back over 443 or 53, which 443 is SSL, which a lot of companies just leave that port open because the proxies can't do much with it. DNS, it'll try that. And it will go as far as it can, even going down to trying to tunnel over ICMP. So if it can't do anything else, it'll revert back to trying to tunnel SSH back up over ICMP to get back to you. So for that, it does have to have an IP address. But this is something that you can easily drop on the network somewhere, put this behind somewhere where somebody may not actually notice that it's there. And it looks like I have managed to successfully crash Stratus. So let's fix that. Sorry, I pulled this out of the Subversion branch. So this is sort of the most cutting edge version, which, as we all know, sometimes has some problems. So let's go ahead and pull this back up. So the really interesting ones, I'm going to see if I can find one, is the MDNS. Here's a Dropbox example, and you've probably heard of the Dropbox stuff in the news recently. One of the cool things about this one is it gives us namespaces, it gives us the port, the version, and it also gives information about the host that it came from. But they found that for the Dropbox, if two people have access to the same thing, and you can get a hold of one of their configuration files, you may not have to provide authentication to get to the Dropbox. So, say I have a CEO. I know that person's using Dropbox, that they may or may not be sharing information with other people. So you can look at this to tell what Dropboxes people are accessing, to be able to figure out how people may be linked together. And say the CEO may not have very many things on their computer. You find a developer that maybe passed somebody that information up. Well, the developers are running some old version of SQL Server. Well, so you may have just gotten access to files in the CEO's Dropbox. So you can use that information to help leverage the information that you found on the network to maybe hack somebody that is a different privilege level to escalate access to documents that you may not have had access to before. So what MDNS does, and I'm still going to look for an example for that, but for MDNS provides information in a lot of cases about what ports are open on a box. And so we can get a lot more information about that. And this is being really slow. So I'm going to go back to slides for a couple minutes, and we'll see what kind of time we have to come back at that in just a minute. Okay. So the way that this works is through a Metasploit framework plugin. Basically, we start off with that pig module, and then it loads all those sub-filters. So the helper filters have a couple of things about them that make them nice. The first one is it has the ability to set what type of packets that filter looks at, which really saves you time as these filters start to grow. You don't have to start parsing each packet and passing each packet in. Basically, it'll look for these matches, and it will try to figure out from there whether or not it should be processed. And let's go look at one of those real quick. Let's pull this back up. So let's look at the SSDP. SSDP is plug and play. So basically we know that with this, the destination MAC is going to be a multicast address. And so we can look for the MAC address of this. We know it's going to be a UDP packet. And so basically we can specify at the Ethernet and UDP layer, all the way, Ethernet, UDP, and IP layers, all the parameters that we want to look for. So as this is going through and parsing these types of packets, your parser will only see these, which helps, if you're lazy like me, you can write a lot dumber parser because you don't have to figure out what the packet is when it gets to you, but it also saves some time because as you have more of these, it's not going to do anything extra. The parse section actually does all the work, and in this case, this is pretty slim. Basically, the Racket framework within Metasploit, which is part of the reason that I use this, pre-parses for you a lot of information. So basically, since I know this is a UDP payload, all that I have to do is specify it as a UDP packet, and then from there, just some very basic parsing, and then report note is what puts it back into our repository. So by using that, we can save a lot of time, both on the parsing side and also on the coding side, because we don't have to do very robust coding. So these are the currently supported filters and what they gather. We're going to go over each one real quick. So CDP is kind of cool. CDP is a Cisco discovery protocol. And what it is used for is for talking between devices to sort of let each other know what's up. Some of the cool things that they share are their OS version, IP information about the switch or router. A lot of the time they'll also share VLAN information. Here are sort of VLAN hopping. Okay, so VLAN hopping, a lot of places you may end up with a voice VLAN and a data VLAN. So one of the things that you can do is you can look at the CDP information, and it'll sometimes just tell you what the voice VLAN is, which that's really handy because it tells us, one, that there is one, and two, what the number is. So at that point, we just have to figure out how to get on it. And there's programs which help automate that. So being able to see that information helps us a lot. It'll also give us management interface information. So that can do two things. One, if there's a separate management network, we can know what that separate management network is. So if, for instance, SNMP either gets or sets to be able to retrieve switch information or set switch information, we can know where those are probably going to have to come from in order to work. And it can also give us some better idea of what the overall topology is. So the other one, another one is DHCP inform. And so what DHCP inform does is once a host has got an IP address, it'll send back out, hey, I got that, that's me now. And it puts out some really fun stuff. First of all, we know the MAC address and associated IP, but it also tells us the host name and the vendor class. And there's also a request list, which is the list of fields that it wants in order to be able to set its information. So the vendor class will tell us generally what operating system it is, whether it's Windows, all that other stuff. The request list lets us fine-tune that. So for instance, Windows XP requests different fields than Windows 7 requests. And sometimes different service packs request different information. For instance, Windows XP Service Pack 2 requests slightly different information than Windows XP Service Pack 3. So we can actually possibly get down to OS identification down to the service pack level using this information. So basically, we don't have to scan anything. It's just sitting there telling us. Dropbox. Dropbox is a fun one because, again, most of the time when we see a Dropbox, it's either going to be a Mac or a Windows box. And it tells us all the namespaces so we can figure out some relationships between people. We know what the Dropbox port is, which more and more security research is being done on Dropbox right now. So the nice part about that one is if there is a Dropbox vulnerability found, it's told you where it lives and what its port is. So you don't really have to go find it, it'll find you. Groove. And Groove is part of the latest Office suite. And it seems to be gaining popularity in corporate culture. And it's sort of awesome for pen testers, which probably means it's not awesome for the rest of us. But it'll tell you things like whether or not a person is online or offline. It'll tell you the port that Groove is running on. But the really nice part is it'll tell you all the IP addresses on the system. It'll tell you all the IPv4 and IPv6 addresses. So for instance, if you're running VMware, you'll see all of the VMware local interfaces. Even though we can't talk to them, you'll see that they're there. So you can get a pretty good idea of whether or not a host is running any sort of virtualization software on there. Also, if it's dual home. So if you see two IP addresses and one of them isn't in a private network, you can sort of get the idea that that host may be bridging networks, and that may be another host that may get you further in a penetration test. And also, you can tell the Groove version. So again, you can do some fingerprinting of that across different versions of Office and figure out more specifically what versions of Office are associated with which one, and do some guesses about the Microsoft Office version. MDNS is probably the most interesting one I've looked at. So what MDNS is, it's also known as Bonjour. The first time I encountered it, it was being used by iTunes to show you all of your friends and who has music that you can listen to or borrow. And it's sort of grown from there and become more mature, and a lot of things are using it. Macs use it for presence information, so if you're using any sort of, I can't remember what the name of the Mac chat program is, but if you want to know if somebody's available, it's sending out multicast packets telling people whether or not you're at the keyboard. That's pretty awesome. It also frequently sends out lists, especially if you're on a Mac, of what ports are open. So you don't have to port scan those guys. They'll just offer it up to everybody. So I love my Mac, but I think it's a whore. So the other one is part of the status information. You'll also get the names of people, and you can also get information about domains. So this has all of the same sort of information that someone would look up with DNS records, only this is multicast. So you can get information about what domain a computer's in, what the machine's host name is, services that it's offering, who owns the machine, ports that are listening, and all of that is just being broadcast freely. And as I unfortunately figured out in the name while I was doing some testing, I hadn't changed the name of my Mac from the default install. So most of these devices by default will be like Ryan's Mac. Well, so really if you're listening on the network and all of these things are broadcasting their host name, you can sometimes figure out which actual people are on the network with you. And sitting in a coffee shop and being like, hey, Bob, they'll be really confused. Not that you should ever do this anywhere where you don't have permission. This is just listening, and I'm not a lawyer. So you can figure that out. SMB goes ahead and gives away lots of information as well. So SBT, which is the SMB over TCP, does a lot of things with broadcast to help you. And some of the things that it sends out are announcements about your OS version. It doesn't do service pack, but you can do major version. You can do Windows XP, Vista, Windows 7, hopefully never Windows ME. But you can also get server client status. So you can tell whether or not file sharing is enabled on that box, or whether it's just a client. You can also tell some Things like SQL Server. I don't know who thought that was a great plan, but it will announce whether or not you have SQL Server installed. This will also help you identify Samba boxes on the network, because if you see anything that has the word Linux in it, it's probably Samba. Also, some of the Samba servers actually identify themselves as Samba. The other plus side is with the host name, it usually gives a domain name. So if you don't know what the Active Directory domain is, and you sit there long enough, you will find out. SSDP, which is the Symptom Service Discovery Protocol, probably simple, but this is plug and play, network plug and play. It's really kind of fun. I was sort of surprised. Usually people use it to find who the network gateway is. So if you're looking at traffic on the network, you'll see requests for gateways go by periodically, and it's used to help, usually Windows boxes find the plug and play enabled gateway on a network. A lot of other cool stuff uses it. Cameras are a big one. So if you plug in at an organization, you're doing a pen test, if you listen for a little bit, there's a decent chance that if they have security cameras on the network, that you will find them. And sometimes there's interesting stuff on there, and sometimes they're not. Also printers are notorious for this. And another one of the modules that I have coming is IPP, because IPP does some printing announcements as well. But for the printers, it gives lots of information about what the capabilities are, down to, can you use this to staple pages together? What's the name? What's the version? Is it running an FTP server? All sorts of information about that. And the SSDP usually presents a URL. And what I'm not doing right now, but sort of the second step is grab a Python script, and that file is XML. You can easily, through Python and Metasploit, I've got some stuff on this on my blog, pull all of a certain type of node out, and then do another function. Since you know it's going to have a URL in it, step 2 is fetch that URL, grab the XML file, and you can get all sorts of additional information. Usually it's configuration information about the device, other ports it may have open, whether or not it has users involved or an FTP server as well, those sort of things. So SSDP is pretty cool. So how do we fix this? So there's a lot of things here, and some of it is easy to fix and some of it's not. NetBIOS. Most places don't need NetBIOS over TCP anymore. It was originally used for sort of work groups where you didn't necessarily know who your peers were. But anymore, for the most part, the peer-to-peer sharing over SMB is getting less and less, and centralized sharing is becoming more and more popular, especially with the cheapness of NAS devices and things like that. So unless there's some overwhelming reason to have NetBIOS over TCP, it's easier just to disable it. For SSDP, the best thing to do is disable network plug and play. And it's amazing how much stuff does have the network plug and play. Everything from computers to your home router to cameras. Even I saw a network webcam that was just a little teeny stupid little webcam that all you could do was you could connect to it and look, and it was broadcasting like 7 or 8 different capabilities. So it's amazing how much some of that stuff has. For CDP, CDP is really nice because it makes it so that if you land on a switch, you can immediately see who your neighbors are. The bad part is everybody else can see too. So if you have good network management and network topologies, in a lot of cases you don't really need CDP. If there are places where it's necessary, so maybe at the core of your network, enable it there and then disable it elsewhere. It will only talk to basically your local segment. So in areas where you don't need it, don't enable it. So DHCP. For the DHCP in forms, there's a concept called DHCP helpers. And what DHCP helpers do is when a switcher router sees a DHCP packet, it goes, hey, I know where that's supposed to go. I don't need to flood this out on my ports. Instead, it will send it directly somewhere else. So it basically cuts down on all of the DHCP broadcasts on your network. That gets you two things. The first thing it does is it makes it so rogue DHCP servers won't screw you. Not that anybody would bring in a Linksys box from home because they couldn't do something that they just hadn't asked for. But it will also protect from information leakage. Dropbox. So I would say if you're in a corporate environment, Dropbox probably isn't what you should be using. But if you're talking about for home use or something along those lines, there is a way to disable LAN sync. For the most part, you don't need to find your buddy in order to upload to Dropbox. Go ahead.
Do you have any good recommendations for a corporate environment? I know this has come up where I work, and they immediately swarm Dropbox.
So there are a number of solutions that utilize Dropbox technology where ideally in a corporate environment, in my opinion, and your mileage may vary, what you really want is the ability to share files with a person or an individual and have an audit trail established and be in control of that data. So there's products like Sterling, and there's even some open source software where you can create user accounts and map drop areas to specific users, be able to audit where somebody got a file from, limit how they can get to it only via secured protocols, etc., and make sure that it stays on your side encrypted until it's delivered. One of the recent problems with Dropbox was they revealed that they're doing data deduplication, which opens some questions about how secure is the data on their network. And also, it appears that they may have the ability to turn your data over to law enforcement, which means that if they can turn it over to law enforcement, then someone clever may also be able to acquire it. Keeping it all local within your environment with a Dropbox technology, regardless of what it is, in my opinion, is preferable. It's more management, but a lot of these have pretty simple UIs. So, for instance, if you have a centralized help desk, they can take over management with it. It's point, click, easy peasy. Can also do things like key-based authentication. So if you have automated processes doing SFTP key based off or SCP based key off.
Do you have any favorites for the open source technology like Dropbox?
I don't. The solution that I have seen used most frequently is not open source, so I do not. His question was, is there a Dropbox style technology that I could recommend? And I don't have a good answer for that one. So Groove is interesting. I haven't found a way to make it shut up. It really wants to tell everybody about the stuff it knows, which is really kind of funny because the whole point is it's really peer-to-peer, so it's not stored. Your data is not stored centrally anywhere, so it can't be stolen centrally from anywhere. And Groove seems to have gained some interest in corporations, especially for people who are doing work from home and things like that, because you can have things stored in different places and they all come back together. I don't have a good answer for that one right now. My best suggestion is if you're worried about that, don't use it. And MDNS, disable it when possible. May not always be an option, but if you're using a Mac or something along those lines, you have the ability to turn off some of its noisiness. And the network panel, you can, first of all, change your name. So if it's Ryan's MacBook, fix that. Also, you can make it say, sorry, I'm trying to remember the verbiage, but you make it not broadcast your status information and other things like that. For other platforms, a lot of them have MDNS servers. You can disable them. To my knowledge, you can't disable that with iTunes, but I may be wrong. Okay, so it apparently is possible to uninstall it, and iTunes will be very sad with you, but iTunes will still let you listen to your music. You just can't borrow from friends. So if people find this interesting and like playing with packets, first of all, I need more data. I have some pretty limited data from places where I've been gathering it. All I really need is broadcast and multicast traffic, so it wouldn't include passwords or any of those sort of things. So it's relatively benign data, and I'm not going to put it on the interwebs or anything like that. But that'll sort of help get a better idea of, in different environments, what kinds of broadcast traffic and multicast traffic are out there, and things that we will find interesting. The other part is the next step for the DHCP stuff is I haven't actually been able to get the mapping done for all of the request types to all the different OSs. The information is out there, but it's just really kind of a little bit tedious. So if anybody's interested in organization, I'll gladly accept help. The other thing is more protocols. And if there's protocols that you're interested in seeing that you know are giving away information, if you want to send me a sample, I'll do my best to break it apart and create a filter. So for the future, right now this is only running out of MSF console and the other Metasploit family. Meterpreter has the ability to do sniffing. So because of the plugin architecture, I'm fairly confident that I can get Meterpreter to do the sniffing and pass it back up for parsing. So as boxes are exploited and you have new points of vantage on the network, you can start gathering information immediately until you're ready to do more interesting things with those hosts. So especially if you're doing any sort of social engineering attack or anything like that, where you're going to start off migrating to another process and just listening until you're ready to actually deal with the host, this is something that would be cool. More protocols, better operating system, IDs, and other types of plugins is where I want to go from there. So here is a place where you can get the code. The data exploits folder has all of the pig plugins, and the modules aux sniffer has the actual pig aux module. That's my Twitter handle and email if you are interested in contacting me. And I'm a little bit short on time, so does anybody have any questions? So the question was, if somebody's using a host-based firewall like Zone Alarm, does that change this? And the answer is maybe. So a lot of the time, there'll be a program that you'll want to use, like iTunes, and it'll say, hey, do you need to allow this? Or you need to allow this in order for this to work. Well, so anytime it says, hey, do you really want to do this? You click yes. So it turns out that for a lot of the stuff, it may still be there just because you've agreed to it. It probably will block some of it, but I would say on a case-by-case basis, your mileage will vary. Cool. Thank you very much.